This is Unit 6, Lesson 2, Solutions to Linear Equations. In class today we talked about the relation x plus y equals 7. It's an equation that relates the two unknown quantities x and y. We talked about how these two relate. The x value and the y value add up to 7. And then we came up with a table of values where the x and y value add up to 7, and we know that those are another way of writing ordered pairs with an x and a y value. And then we showed that when you graph those, they all line up in a line, and that there's actually a whole lot of other ordered pairs that would satisfy that equation where the x and y value add up to 7. And so we show those by drawing a line through all of those, because we know the other ones will line up as well with arrows at the end. So let's consider another example, example 1. Here's a new relationship between x and y equals 3x. So take a minute and write down what you think that means in words. All right, we could say that the y value is 3 times the x value. Now that's a relationship that's pretty easy to understand, and come up with some x and y values in your head that would satisfy that. So what we're trying to do here are create the solutions to the equation y equals 3x. A solution is any set of two numbers written in an ordered pair that when plugged in make it a true statement. So we're going to list those solutions in our table. What if x was 1? Well, when we plug that in, 3 times 1 makes 3, and so the y value would be 3. What if x was 2? Well, we know that 3 times 2 is 6, so the y value would be 6. So these are probably some solutions that you could come up with in your head. What are some others? When x is 3, the y value would be 9. When x is 4, the y value would be 12. But remember, we don't have to pick only integers or only positive values. We can pick any value we want for x, and there's going to be a matching y value that goes with it. So what if we picked 0 for x? Well, 3 times 0 would make 0, so the ordered pair 0, 0 is also a solution to this equation. What about if x was negative 1? Then our y value would end up being negative 3, because negative 3 is equal to 3 times negative 1. So that's another solution to this equation. What if we picked a number like 200? Well, 3 times 200 is 600. So the ordered pair 200, 600 is also a solution to the equation y equals 3x. Well, we picked a decimal, 2.7. Well, 3 times 2.7 is 8.1, so that's also a solution. So we've listed some solutions to this equation in a table called a table of values, but we know that this is just another way of writing the ordered pairs that represent the solutions to this equation. Here they are written as ordered pairs. Let's consider example 2. What do we think this relationship can be described in words? How can we describe it in words? Let's see. Well, the y value is 5 less than 2 times the x value. That's from our translating words to symbols, and this is a little bit harder to figure out the x and y values that would make that a true statement, because it's a little bit more complicated a relationship. So rather than thinking of them in our head, we can use that equation to come up with the pairs that are solutions. So if I choose an x value of 1, I can go ahead and plug it into the equation in the spot where the x is 1, and then simplify and get y is equal to negative 3. So then I can go ahead and put the negative 3 in the table along with that. So I can choose various x values. What if I chose 2? Well, I can plug it in the spot in the equation for x. So I would say y equals 2 times 2 minus 5, plugging in 2 for x, and then simplifying and coming up with y equals negative 1. So I can put the negative 1 in my table as well. What if x was 3? Well, then we would plug in 3 in place of x. You can see, simplifying, we would get 6 minus 5, or 1. So we can go through this process and come up with any set of x and y values that would make that statement true. So that would be solutions to that equation. So again, what if we choose a large value for x? Well, we just plug it in, And you can see that we would get 400 minus 5, which is 395. So there's another solution. We can pick negative numbers. What if we chose negative 1? Plug in negative 1, simplify, and get negative 7. And what if we chose a decimal? That works too. Plug that in, and we come up with the y value of 7.6. Now again, this process is finding a whole lot of ordered pairs that are solutions to this equation. Are they the only ones? No, there's a whole lot more. There's actually an infinite number more. We can't list them all, but we can list some of them. Remember, these are just some of the solutions. There's a whole lot more. Example 3, here's another relationship, and we'd like to find some solutions. So I pick an x value, plug it in, solve, and come up with the y value that matches. Y is 6. If I choose a value like negative 1, you can see when I plug that in, I'm going to get a fractional value, but that's okay. So my answer is 7.5, the y value. So I'd like you to go ahead and fill in your table with the x values that are shown here in the video, and then complete the rest of the table filling in the y values. And you can check your answer once you're finished. When x is 0, y is 8. When x is 2, y is 9. When x is 6, y is 11. And when x is 100, y is 58. These are all solutions to the equation y equals 1/2 x plus 8. In example 4, we're going to be doing the same process, but it's presented in a slightly different way. Here we've got some ordered pairs that we want to be solutions to this equation. But there's one of the pieces missing from the ordered pair, just like there was in our table of values. So in 4a, we're given an ordered pair in which the x value is 3, but we're missing the y value. So we'd like to do the same thing we did before. We're going to plug in 3 for the x value and simplify to find out the y value is negative 10. We can write it right there in our ordered pair. 3, negative 10 is a solution to this equation. Now in 4b, we've got the x value is missing and the y value is 6. So in that case, we're going to plug in 6 for the y value and leave the x as it is to solve for the x. Now solving this is a little bit more complicated in that we have to undo just like we would normally do to get the x isolated. So we're going to first subtract 2 from each side, and then you can see and proceed to solve just like we would normally and come up with x is equal to negative 1. So we can go ahead and plug in negative 1, so negative 1, 6 is a solution to this equation. I'd like you to try C and D on your own. Go ahead and then check back in when you're done. All right, for C, we've got an x value of negative 5, so we're plugging in negative 5 in the spot where the x is, and coming up with the y is negative 18. And in 4D, it's the y value that's negative 6, so we're going to plug in a negative 6, and then solve by subtracting 2 from each side, just like we did before, and proceeding to get the x value is 2. So 2, negative 6 is the solution to this equation. All right, example 5. Here I'm asking, is 3, negative 8 a solution to this equation? The way we can do that is by plugging it in, 3 for x and negative 8 for y, and seeing if it makes a true statement. So I'm going to plug in a negative 8 for the y slot, and then a 3 for the 5, and I'm going to simplify each side and come up with negative 8 equals negative 12, which we know is not a true statement. Therefore, no, 3, negative 8 is not a solution to y equals 3 minus 5x. 5b, is negative 4, negative 2 a solution to 3x minus 9y equals 6? I want you to give it a try and then come back and check when you're done. All right, when we plug in negative 4 for x and negative 2 for y, this is what it looks like. We simplify each side. It comes out 6 equals 6. Oh, my 6 is blue for some reason. Yes, it is a solution. That's it. Put your note sheet in your binder. I'll see you tomorrow.